You've found Dreamtime Science, a peaceful corner where we unravel the mysteries of our universe one whisper at a time. Let the gentle current of discovery carry you towards sleep. You know, I've been thinking about how something invisible can be so powerful. Pressure is one of those quiet forces that's always around us, yet it can do incredible things. It's remarkable how pressure can squeeze a submarine deep underwater, or even steer the patterns of weather we see in the sky. I'm really excited to share with you how this invisible weight shapes our world in surprising ways. A soft tap of the like button or a whispered subscription tells me these calming discoveries resonate with you. What aspect of science brings you the most wonder? Before we begin, create your sanctuary. Nestle into your chosen spot. Let your muscles soften and allow your breath to find its natural rhythm. Close your eyes, if you will, and let the world around you soften at the edges. In this gentle hush, a silent presence enfolds you, constant, unnoticed, yet shaping every moment of your life. It presses upon your skin, fills your lungs, and tugs softly at the surface of every pond and cloud. This is the invisible hand of pressure, a force so familiar that perhaps you have never paused to sense it. Tonight, let us drift beneath its surface, exploring the secret stories it tells in our culture, our imaginations, and the myths that have swirled around it since ancient times. Pressure, in its purest scientific sense, is simply force distributed over an area. This definition, so stark in its clarity, hides a world of marvels. The air itself is a sea, a restless ocean of molecules, each one darting and colliding in a dance choreographed by temperature and gravity. The weight of all those air molecules above us, from your rooftop to the edge of space, creates a pressing force on every square inch of your body. At sea level, this amounts to about 7 pounds on every square inch, roughly the weight of a bowling ball on each patch of skin the size of a postage stamp. Yet we feel nothing. Why? Because the pressure is everywhere, inside and out. Your blood, your lungs, your very cells, all push back in perfect balance. There is a certain poetry in this equilibrium. It is the reason we do not collapse beneath the atmosphere's weight, nor float away into the waiting stars. It is the silent agreement between your body and the air, a pact that is rarely broken. Yet in our minds and our stories, pressure seldom stays so invisible. It becomes the instrument of drama and transformation. From the earliest myths, pressure has been a metaphor for challenge, for the force that shapes destinies and mountains alike. In the old tales, the earth itself was once soft and malleable, molded by gods who pressed valleys into being with their hands. The pressure of the heavens, it was said, kept the sky from falling down, while the pressure of the underworld threatened to erupt as volcanoes and geysers. The ancient Greeks, for instance, imagined the Titan Atlas bent beneath the pressure of the sky, condemned to hold up the firmament for eternity. They saw in his struggle the weight of responsibility, the strain of forces beyond human control. In China, the myth of Pangu tells of a giant whose body pressed apart the earth and sky, his every breath inflating the world we know. Pressure, in these stories, is both creative and destructive, a force that can birth mountains or shatter them. Science fiction, too, has long been enchanted by the theme of pressure, though here its manifestations are often more literal, more deadly, more strange. Martian explorers fear the crushing embrace of an alien atmosphere, or the vacuum that waits beyond a cracked helmet. Submariners dive into the deep, where pressure mounts relentlessly with each meter, threatening to implode even the strongest hull. Writers have woven entire universes from the tension between pressure and its absence, painting worlds where human life teeters on a razor's edge. But what is it truly that makes pressure so captivating in our stories? Why does it haunt our dreams of distant planets and sunken ships? Perhaps it is because pressure, though invisible, is always at the threshold of disaster and wonder. It is the unseen line that once crossed brings transformation or destruction. A submarine's hull, designed to withstand the weight of 1,000 atmospheres, groans and shudders at depth. A spaceship cocooned in fragile metal holds back the void itself. In both, there is a constant, silent negotiation, as if the universe is reminding us how fragile our boundaries really are. This fragility, and the myths that grow up around it, have given rise to some enduring misconceptions. The vacuum of space, for instance, is often depicted as a place where an unprotected human would explode, as though the body were a balloon suddenly untied. The truth is less dramatic, but no less fascinating. The human body is resilient, its fluids contained by strong tissues and skin. Without pressure, yes, water in the mouth and eyes would begin to boil at body temperature, and unconsciousness would follow within seconds, but the body would not burst apart. Instead, it is the gentle, inexorable escape of air from the lungs and the swelling of skin that mark the real dangers. Pressure, in its extremes, does not always announce itself with thunder and spectacle. Sometimes it is a whisper, a subtle shift. Consider the bends, or decompression sickness, a peril faced by divers who ascend too quickly from the depths. Here, the pressure of the water keeps gases dissolved in the blood, like soda in a sealed bottle. Rise too fast, and the pressure drops swiftly, forming bubbles that can rack the body with pain, confusion, or worse. It is a reminder that pressure is not merely a number on a gauge, but a living relationship with our environment, a dance that must be respected. In the realm of industry and invention, the myths of pressure persist. Steam engines, those iron horses of the 19th century, were once rumoured to be powered by the raw strength of compressed fire, as if the pressure inside their boilers was a kind of bottled lightning. The reality is both more mundane and more magical. It is the simple expansion of water vapour, the ceaseless push of molecules seeking room to roam, that drives the pistons and wheels. Yet the image of pressure as a caged beast endures, fueling tales of runaway engines and exploding boilers, of men who gambled with the invisible hand and lost. Pressure's cultural associations are not limited to the physical world. The very language we use is saturated with its metaphors. We speak of pressure to perform, of pressure cookers in politics or sports, of feeling under pressure in times of stress. In these phrases, physical pressure becomes psychological, a weight upon the mind, a force that shapes decisions and destinies. The invisible hand presses here too, sculpting the stories of our lives. In the arts and in literature, pressure is both antagonist and muse. The poet Emily Dickinson wrote of the pressure of the storm, describing not merely the weight of air, but the burden of emotion, the tension before revelation. In music, the build-up of pressure, real or imagined, is the essence of drama, the crescendo before release. The painter captures the pressure of atmosphere in the blurred horizon, the density of colour, the softness of a cloud. Pressure, though unseen, is everywhere in the world we create. And yet, amid all these stories, a certain fear flickers at the edges. Pressure is a force that cannot be seen or touched, only felt in its consequences. It is the silent threat in the deep ocean, the lurking danger in the hiss of steam, the ever-present risk of collapse. This fear is not irrational. It is rooted in our biology, our evolution. For early humans, the pressure of a storm signaled danger, lightning, wind, flood. The pressure changes before a hurricane or tornado are still sensed by animals, whose bodies respond in ways we are only beginning to understand. The myths of pressure are also born from our attempts to master it. The alchemists sought to harness the pressure of vapours in their alembics and retorts, dreaming of transmutation and immortality. The early chemists and physicists invented the barometer, the aneroid, the pressure gauge, tools that made the invisible visible, that allowed humanity to measure and at last to control. Yet each new instrument brought its own myths, its own misunderstandings. The mercury in Torricelli's barometer was once believed by some to be alive, to rise and fall with the moods of the heavens. The pressure in a sealed bottle was a spirit waiting to escape. In modern times, the myths have grown more scientific, but no less fantastical. The idea that pressure alone can crush diamonds or create new worlds is a staple of speculative fiction, and indeed, deep within the earth, pressure and heat do transform carbon into diamonds and dust into stone. But it is not pressure alone. It is a symphony of conditions, temperature, time, chemistry, playing out over epochs. The stories we tell about pressure, then, are stories about boundaries. Where does safety end and danger begin? How thin is the membrane that separates life from lifelessness, order from chaos? In the tales of deep-sea divers and astronauts, in the legends of sunken cities and lost continents, pressure is both barrier and invitation. To cross its threshold is to risk everything, but also to discover. Pressure's invisibility is perhaps its greatest mystery. You cannot see it, not directly, only its effects. The bowed glass of a deep-sea submersible, the flutter of a weather vane, the swelling of a balloon. In laboratories, scientists use manometers and sensors to coax pressure into revealing itself, to translate it into numbers and graphs. Still, the hand itself remains unseen. At times, pressure reveals itself in the most unexpected ways. When a storm approaches, the air may feel heavy, a subtle pressure in the sinuses or an ache in the joints. Birds grow restless. The world seems charged, expectant. This sensitivity is not magic but physiology. Our bodies are attuned to the invisible shifts around us, even when our conscious minds are not. And so, the invisible hand of pressure guides us, shaping our stories and our science. It is the force behind the winds that sculpt deserts and drive ships across oceans. It is the agent of change in the voyage of magma, the rise and fall of tides, the crack of a thunderclap. In every bubble that rises from the deep, in every breath you take, pressure is at work, silent and tireless. Yet, for all its power, pressure does not act alone. It is part of a great tapestry of forces, temperature, gravity, chemistry, each pulling and pushing, balancing and yielding. The myths that surround pressure are, perhaps, a reflection of our longing to find meaning in this invisible negotiation. To see in the play of forces a story that is both personal and cosmic. As you lie in the hush of your room, the pressure of the world presses gently upon you, holding you to the earth. It is a comfort, an embrace, a promise that the invisible hand is always there, steady and constant. The stories we tell about pressure, of gods and titans, of explorers and survivors, are, in the end, stories about this embrace. They remind us that, though we may not see the hand, we feel its touch in every moment. Beyond the horizon of our senses, pressure continues its ancient work. In the depths of the sea, in the vaults of the sky, in the hollow silence of space, it shapes the world anew. And just as the myths have always promised, those who seek to understand this invisible hand will find themselves drawn to the thresholds it guards, to the places where balance trembles and new stories begin to unfold. The journey into the heart of pressure is only at its beginning. The hand that presses is also the hand that lifts, and the next chapter awaits in the spaces where the invisible becomes seen. In the quiet hush of your room, as you lie between waking and sleep, the world outside continues to press upon you, softly, steadily, ceaselessly. This touch is not that of fingers upon skin, nor the weight of a blanket on your chest. No, it is something subtler and more profound. The invisible yet inescapable caress of pressure. It is everywhere, and though it slips past your senses unnoticed in most moments, it shapes your every breath, sustains your very blood, and sculpts the landscapes of earth and sky. Let us drift deeper now into the complex, wondrous dance of pressure, a force as gentle as a sigh and as mighty as the tides. To begin, allow yourself to become aware, if only in imagination, of the sea of air that envelops you. Each molecule, Oxygen, nitrogen, argon, and a breath of other gases careens about, colliding with its neighbours in a wild, ceaseless ballet. The invisible is made present in these collisions, for it is in their sum that pressure arises. Every square centimetre of your skin, every curve and hollow, is being struck by countless air molecules every second. The sheer number, the wild speed, together they make the atmosphere's weight, pressing down with the quiet insistence of 10,000 kilograms on each square metre. Yet this pressure is not felt as weight, not in the way you feel a book pressing on your lap or the gentle grip of gravity as you lie in your bed. Atmospheric pressure at sea level is about 101,325 pascals, a unit named for Blaise Pascal, the philosopher and mathematician who sought to measure the very breath of the world. Imagine stacking a column of mercury, nearly 76 centimetres tall, in a tube. The pressure at its base equals the weight of all the air above you, pressing down from the top of the atmosphere to the ground. In this way, pressure is a measure of potential, of the energy stored in the restless movements of molecules. But pressure is more than a static weight. It is a force of movement and change, a difference that drives winds across continents and currents through your veins. Press your palms together, pressurizing the air between them, and you create a localized region where the density of molecules is momentarily higher. Open your hands, and the air rushes in to fill the void, seeking equilibrium. Nature abhors a vacuum, and in that gentle rush, you sense the longing of the universe for balance. Pressure is not only a matter of air and weather. Dive beneath the surface of a calm pond, and you feel the water's embrace tighten with each metre descended. The pressure here is not only the weight of the air, but of every drop of water above you, each layer adding its own burden. At 10 metres depth, the pressure doubles from that at the surface. 2 atmospheres, one from air, one from water. This is why your ears ache as you descend, why submariners and divers alike must respect the invisible hand that presses ever harder with depth. Consider, too, the wondrous fact that the cells of your body are vessels of pressure. Each cell, a tiny world, maintains an internal balance, a turgor, a tension, between the salty fluids within and the liquids without. Should this balance falter, the cell swells or shrivels, life itself imperiled by the simplest of forces. Your blood, too, pulses with pressure, surging from the heart in waves that ripple through your arteries and veins. It is this pressure, the blood pressure measured by a doctor's cuff, that keeps oxygen flowing to your brain, that lifts you from sleep each morning. Yet for all its familiarity, pressure is a concept that slips through our fingers when we try to grasp it fully. It is both everywhere and nowhere, a property of matter and of space itself. Scientists have long debated how best to describe it, to capture its essence in equations and words. Is it a scalar or a vector, a directionless quantity, or one that points and pushes? In fluids, pressure acts equally in all directions at a point, a curious truth that defies our everyday sense of force. Lay your hand in water, and the pressure presses not just downward but sideways, upwards, every which way, seeking no particular path. This isotropy of pressure is what allows divers to be squeezed from all sides without being crushed in a single direction. It is why a balloon inflates evenly, not lopsidedly, and why a bubble rises through water as a perfect sphere, nature's most efficient shape for containing and distributing pressure. Yet the moment pressure is unbalanced, when a tire bursts, an aneurysm ruptures, a volcano erupts, the results can be sudden and catastrophic. The dance of pressure is not only one of gentle equilibrium, but also of explosive transformation. In the weather, pressure draws the very winds that shape our days. High above, in the vast reaches of the troposphere, columns of air are warmed by the sun and rise, creating lows. Elsewhere, cool air sinks, creating highs. The difference, sometimes only a few millibars, is enough to set whole air masses in motion, to summon the breezes that rustle leaves or the gales that lash the coasts. Storms are born in these gradients, hurricanes spin from the imbalance, tornadoes twist from the meeting of hot and cold, high and low. Yet the complexity of pressure extends far beyond these physical effects. For centuries, thinkers have pondered its nature, seeking to understand how a collection of particles, each moving randomly, can together exert a steady, predictable force. In the 17th century, Daniel Bernoulli imagined the air as a swarm of tiny, bouncing spheres, their impacts on the walls of a container adding up to the pressure he could measure with mercury and glass. Later, Ludwig Boltzmann and James Clerk Maxwell wove this vision into the kinetic theory of gases, revealing that temperature, volume, and pressure are three faces of the same underlying dance of molecules. The higher the temperature, the faster the molecules, the greater the pressure, if the walls hold steady. But here, the limits of our understanding emerge. For pressure is not, strictly speaking, a property of any one molecule, but of their collective. In the microcosm, at the level of quantum mechanics, the very idea of a definite pressure becomes murky. Molecules do not possess a location or velocity with certainty, only probabilities. Pressure, then, becomes an emergent property, something that arises not from the behavior of individuals, but from the averaging of multitudes. It is a macroscopic truth born from microscopic chaos. The complexity deepens further in strange and extreme realms. Deep beneath the Earth, in the hearts of planets and stars, pressures soar to unimaginable heights. In Jupiter's core, hydrogen is squeezed until it behaves not as a gas, nor even as a liquid, but as a metallic fluid, conducting electricity and generating magnetic fields. In the Sun, pressure is so intense that atoms are stripped of their electrons, forming a plasma, a fourth state of matter, where nuclei and electrons dance free. Here, pressure is not only a force, but a crucible, forging new elements in the furnace of nuclear fusion. And at the farthest edge of comprehension, pressure becomes entangled with the very fabric of space and time. In the vacuum of the cosmos, the so-called vacuum energy, a pressure with no mass, no particles, may be driving the expansion of the universe itself. Dark energy, mysterious and pervasive, exerts a negative pressure, causing galaxies to race apart, space to stretch, time to accelerate. Here, pressure is not only the touch of matter on matter, but a property of nothingness, a whisper woven into the structure of reality. Even in the everyday, pressure resists easy understanding. Why does suction hold a piece of paper against a vacuum cleaner's nozzle? Not because the vacuum pulls, but because the pressure of air on the far side pushes. Why do our ears pop in elevators or airplanes? The pressure outside changes more quickly than our bodies can adjust, and our eardrums stretch or contract, seeking equilibrium. Why can a steel ship float on water? Because the pressure beneath it, spread over a wide area, balances the weight above, a delicate interplay of buoyancy and gravity. In the laboratory, pressure reveals its subtleties in countless ways. Consider the mercury barometer, a device so simple yet so profound. A glass tube, sealed at one end, is filled with mercury and inverted into a dish. The column falls, leaving a vacuum at the top, and the height of the mercury measures the atmospheric pressure. It is not that the vacuum pulls the mercury upward, but that the weight of the air outside pushes it up, balancing the column. Here we see the truth. Pressure is not a force that pulls, but always one that pushes, that seeks to fill every void, to balance every difference. In modern science, pressure is not a single number, but a tensor, a way of describing how forces are distributed in every direction, in every tiny volume of space. In solids, pressure can become stress, leading to cracks and fractures, earthquakes and avalanches. In fluids, it remains uniform, but can still drive the most complex flows, the eddies of rivers, the circulation of oceans, the patterns of hurricanes. In plasmas and strange quantum materials, pressure can take on still stranger forms, guiding the behavior of electrons, shaping the properties of matter itself. The limits of our understanding are not only mathematical, but philosophical. Is pressure a real thing, or only a convenient abstraction, a way of summarizing the behavior of countless particles in a single, manageable number? Can we truly say what pressure is, or only what it does? The more we study, the more we find that pressure is at once concrete and elusive, tangible and abstract, rooted in the deepest laws of physics, yet experienced most intimately in the everyday. Pressure, then, is a kind of music, a harmony of collisions and differences, a rhythm that moves through air and water, through bone and blood, through stone and star. Its presence is everywhere, yet it hides from our senses, revealed only when it changes. When a storm approaches, an altitude shifts, a body dives or soars. It is the silent companion of every traveller, the unseen hand that sculpts mountains and valleys, that shapes clouds and winds, that sustains the very spark of life. As you lie beneath your covers, the air presses gently upon you, the blood in your veins pulses with its own internal pressure, the cells of your body maintain their delicate turgor. You are, in every moment, at the intersection of countless pressures, atmospheric, hydrostatic, osmotic, mechanical. Each one is invisible, yet inescapable, weaving you into the fabric of the universe. The dance of pressure continues, unseen but unfailing, a force as ancient as the stars and as intimate as your next breath. And yet, as we surrender to the dark and to dreams, another realm of pressure beckons, a world where the boundaries between air and water, solid and liquid, begin to blur, where the dance of molecules takes on new steps, and the very meaning of pressure is tested at the edge of solidity. In this twilight zone, the mystery only deepens, and the story unfolds anew. Consider, if you will, the dawn-lit workshop of an alchemist centuries ago. In the hush before morning's bustle, glass vials and copper tubes rest on rough-hewn benches, and a single bead of mercury gleams within a slender column, poised for revelation. The air, thick with the scent of wax and parchment, is alive with a single, unvoiced question. How does one make the invisible tangible, the weightless weight of air measurable? To comprehend pressure, not as a whisper on our skin or the ache in our eardrums, but as a physical quantity, a force distributed over area, was to open the door to a new age of science. Yet, in those early centuries, pressure was a ghost, a shadow cast by the interplay of matter and motion, sensed but never truly seen. The first step toward understanding, then, demanded ingenuity. The crafting of instruments, the architecture of experiments, the birth of devices capable of coaxing numbers from the silent press of fluids and gases. Let us visit, in reverent imagination, the laboratory of Evangelista Torricelli in Florence in the year 1643. The Medici city is a hub of commerce and curiosity, its streets echoing with the footsteps of scholars and merchants alike. Torricelli, a student of Galileo, has taken a glass tube, sealed at one end, and filled it with the heavy, shimmering liquid mercury. Inverting this tube into a basin of the same quicksilver, he observes a curious effect. The mercury falls, leaving a void at the top of the tube, but it does not drain entirely. Instead, it stabilizes at a height of about 76 centimeters above the surface in the basin. What is this unseen hand holding the mercury aloft? Torricelli's insight is profound. It is the weight of the air above the basin, the vast ocean of atmosphere pressing down upon the exposed surface that supports the column within the tube. The empty space above the mercury, what we now recognize as a near-perfect vacuum, speaks to the absence of matter, a concept still radical in his day. With this elegant experiment, Torricelli invents the first barometer, a tool that translates atmospheric pressure into the simple, readable language of length. The barometer is more than a device. It is a philosophical instrument, rendering the intangible palpable. For the first time, the pressure of the air is not merely a theoretical abstraction, but a measurable, variable quantity. Its fluctuations announce themselves in the rise and fall of the mercury column, echoing through centuries in the predictions of storms and the navigation of ships. The barometer becomes a sentinel at the threshold of weather and a harbinger of the science of pressure. Consider, then, the further refinement of our tools. The aneroid barometer, a marvel of Victorian engineering, in which a sealed, flexible metal chamber contracts and expands with changes in external air pressure. No mercury is needed, only the delicate interplay of springs and gears translating atmospheric shifts into the motion of a needle across a dial. The aneroid barometer finds its place in the pockets of explorers and the dashboards of aircraft, its heart quietly beating in tune with the breathing atmosphere. Yet the atmosphere is only part of the story. To understand pressure in its full majesty, we must follow its flow into the realm of water and oil, the hidden chambers of the earth, the veins and arteries of living beings. Enter the manometer, an instrument as simple as it is profound. 2 arms of glass, joined in a U-shape, cradle a column of liquid, often mercury, sometimes water or oil. One arm is exposed to the pressure to be measured, the other to a reference pressure, perhaps the open air. The difference in liquid heights reveals the pressure difference between the 2 arms, a mechanical translation of force across the boundaries of matter. In the laboratories of the 19th century, the manometer becomes indispensable. It is used to measure the pressure of gases in chemical reactions, to calibrate engines, to probe the behavior of steam. Through the manometer, researchers are able to quantify the force exerted by the kinetic frenzy of molecules, to infer the invisible collisions that give rise to pressure at a microscopic level. The manometer's silent testimony underpins the development of thermodynamics, the science of heat and motion, and the understanding of the gas laws that govern our atmosphere and our engines alike. Pause now to appreciate the elegance of the Bourdon gauge, a device conceived by Eugène Bourdon in 1849. Its soul is a flattened coiled tube of metal, sealed at one end, the other open to the pressure under investigation. As pressure increases within the tube, it seeks to straighten like a wound spring yearning for release. This motion is transmitted through a system of levers and gears, ultimately moving a needle across a dial. The Bourdon gauge is robust, adaptable, and capable of measuring pressures far beyond the reach of delicate columns of liquid. It finds its home in the boilers of the Industrial Revolution, the pipelines of the oil age, the cockpits of jet airplanes. Each of these instruments, the barometer, the manometer, the Bourdon gauge, represents not only a triumph of engineering, but an evolution in our way of thinking about pressure. They are translators, mediators between the silent world of atoms and the conscious world of human perception. In their readings, abstract forces are rendered as numbers, as dials and columns, as tangible as the ticking of a clock. But tools alone are not enough. The progress of science demands experiment, a dance between question and answer, between expectation and surprise. It is here, in the crucible of experimentation, that pressure reveals its most subtle secrets. Return for a moment to the Parisian salons of the 17th century, where Blaise Pascal conducts his audacious investigations into the nature of atmospheric pressure. Inspired by Torricelli's barometer, Pascal wonders, does atmospheric pressure vary with altitude? He enlists his brother-in-law, Florent Perrier, to carry a barometer up the slopes of the Puy de Dôme, a dormant volcano rising above the plains of central France. As Perrier ascends, the column of mercury in the barometer falls, demonstrating that the pressure of the air decreases with height. The atmosphere, once thought to be infinite and unchanging, is now understood as a finite ocean, thinner at the mountaintop than at the sea. This experiment is more than a measurement. It is a revelation. It confirms that the air itself has weight, that its pressure is not immutable but a function of height, of weather, of the restless currents that swirl around our planet. It is a triumph of both reason and ingenuity, a testament to the power of tools wielded in the service of curiosity. Let us turn then to the laboratory of Robert Boyle in England, a place of brass and glass, of philosophical discourse and careful observation. Boyle's air pump, a device of pistons and valves, allows for the creation of partial vacuums, the rarefaction of air. Within this controlled environment, Boyle and his assistant Robert Hooke conduct a series of experiments, measuring the pressure and volume of trapped air. The result is Boyle's law. At constant temperature, the pressure of a gas is inversely proportional to its volume. Compress the air, and its pressure rises. Allow it to expand, and its pressure falls. This relationship, deceptively simple, is a cornerstone of physical science. It links the macroscopic behavior of gases to the microscopic world of molecules in motion. The air pump, like the barometer before it, becomes a gateway to understanding, a means by which the invisible can be made manifest. Across the centuries, the study of pressure has inspired ever more ingenious experiments. In the 19th century, Otto von Guericke stages a dramatic public demonstration in the German city of Magdeburg. He constructs two large hemispheres of metal, fits them together, and evacuates the air from within using a pump. 30 horses, harnessed in teams of 15, strain to pull the hemispheres apart, but fail. When air is allowed back in, a gentle tug is all it takes to separate them. Guericke's Magdeburg hemispheres provide a visceral demonstration of the force exerted by atmospheric pressure, a spectacle that captures the imagination of all who witness it. Within the biological sciences, the measurement of pressure has yielded insights into the most intimate processes of life. In the quiet chambers of a physiologist's laboratory, a fine glass tube is inserted into the artery of a living animal, connected to a rotating drum covered with smoked paper. Each pulse of the heart sends a wave of pressure through the tube, inscribing a trembling line on the drum's surface. This is the birth of the sphygmograph, the precursor to the modern blood pressure cuff. Through such instruments, the pressure of blood becomes a window into the health of the body, a vital sign as fundamental as breath or temperature. In the depths of the ocean, pressure becomes an adversary to be measured and endured. The invention of the piezometer, a device for measuring the pressure of fluids at great depths, allows explorers to probe the crushing darkness beneath the waves. Submersibles and diving bells are equipped with gauges that register the relentless increase in pressure with every fathom descended. Here, the study of pressure becomes a matter of survival, of engineering hulls and bodies alike to withstand the weight of the world above. Not all triumphs are without their trials. The study of pressure has been fraught with peril and uncertainty. Early barometers, filled with toxic mercury, posed hazards to those who used them. The quest to create reliable vacuums tested the limits of glass-blowing and the patience of generations of experimenters. The measurement of high pressures required ever stronger materials, ever finer tolerances, and sometimes ended in shattered glass and ruined apparatus. Yet out of these tribulations have emerged new ways of measuring, new kinds of sensors. In the modern era, pressure is no longer measured solely by the rise and fall of liquids or the flex of metal. Electronic sensors, built from piezoelectric crystals, generate a tiny electric current when compressed by the force of pressure. These crystals, cut from quartz or ceramic, are the beating heart of countless instruments, from the tire pressure gauges in our cars to the altimeters in our smartphones. Strain gauges, thin ribbons of metal whose resistance changes when stretched or compressed, are glued to the surfaces of aircraft wings and bridge supports, silently monitoring the stresses of wind and weight. The digital age has ushered in a new era of pressure measurement, one in which readings can be taken remotely, logged automatically, and analyzed by computers in real time. Pressure sensors, no larger than a fingernail, travel aboard spacecraft and weather balloons within the engines of rockets and the chambers of artificial hearts. They are the unseen sentinels of our technological civilization, translating the silent language of pressure into streams of data, into the pulse and rhythm of modern life. Yet, for all our ingenuity, pressure remains a phenomenon of subtlety and depth, resisting our attempts at complete mastery. Instruments must be calibrated, their readings corrected for temperature, altitude, and the quirks of their own construction. The challenge of measuring extremely high or low pressures within the core of the Earth, the vacuum of space, or the heart of a supernova demands ever greater precision and creativity. In the quiet moments of night, when the world is still and the air presses gently on your skin, consider the legacy of those who have sought to understand this most fundamental of forces. From mercury columns in candlelit rooms to electronic sensors pulsing in the darkness between worlds, the story of pressure is a story of tools and trials, of triumphs hard won and questions yet unanswered. And so, as the soft tick of barometers echoes through the centuries, we find ourselves poised at the edge of further discovery, listening for the next whisper from the invisible hand that shapes our world. The journey continues deeper and further into the currents and patterns that pressure weaves through the fabric of matter and the tapestry of the cosmos. And so, as the night deepens and the air grows still, let us turn our gaze inward and outward, toward the elusive, invisible force that has threaded its way through every moment of our journey. Pressure, the silent sculptor, the tireless pulse, the agent both of destruction and creation. To contemplate pressure is to contemplate the very heartbeat of existence, and to sense, just beneath the surface of things, a world ceaselessly in motion and negotiation, a world held together and sometimes torn apart by invisible hands. Pressure, in its most elemental sense, is the act of one entity pressing upon another. It is the force distributed over an area, the gentle push of air against your skin on a summer afternoon, the weight of the ocean upon the abyssal plains, the subtle strain within the walls of your chest as each breath fills your lungs. Yet this simple definition belies a universe of subtlety and implication. For pressure is not just a measure of force, it is a measure of relationship, of the way matter and energy commune, contest, and yield. Pressure is a mediator, a messenger, and a mystery. Consider for a moment how pressure is the silent architect of the cosmos. In the heart of a collapsing star, the battle between gravity and internal pressure shapes the fate of worlds. As matter is squeezed to unimaginable densities, the resistance of particles, quantum in nature, unfathomable in consequence, pushes back against gravity's inexorable pull. When gravity wins, a black hole is born. When pressure holds its own, a neutron star or a white dwarf remains, a monument to the balance of forces. But the influence of pressure is not confined to the cataclysms of distant galaxies. In the soft, pulsing tissues of our own bodies, pressure is life itself. The act of inhaling, a motion so familiar as to be almost invisible, is in fact a dance of pressures. The diaphragm contracts and descends, enlarging the thoracic cavity. This increase in volume lowers the pressure inside the lungs relative to the outside atmosphere, and air flows in, drawn by the universal tendency of pressure to seek balance, to smooth out gradients and erase differences. With each breath we become unwitting participants in a grand dialogue between the internal and the external, the body and the world. The circulation of blood is another symphony of pressures. The heart, that tirelessly working muscle, generates waves of force with each contraction, sending blood surging through branching vessels. Systolic and diastolic, the rhythmic rise and fall of pressure echoes the cycles of day and night, of waking and sleeping. The pulse at your wrist is a tactile reminder that within you, pressure is not a static quantity, but a living, fluctuating presence, a signal and a sustainer. Should that pressure falter or surge beyond its proper bounds, the consequences are immediate and dire. Faintness, pain, the threat of collapse. Our well-being is inextricably bound to the maintenance of these invisible gradients. On a grander scale, atmospheric pressure is the breath of the planet itself. The rise and fall of barometric pressure shapes the winds, stirs the oceans, drives the ceaseless churn of weather. High pressure brings clear skies and calm. Low pressure invites storms, tumult, and renewal. In every forecast, in every cloud that drifts across the sky, there is the imprint of pressure's hand. And for all our technological prowess, the full complexity of these exchanges remains beyond our complete understanding. The atmosphere is a restless sea, and pressure is its tide. Yet pressure is not only a physical phenomenon, it is, in a sense, the language of nature's desire for equilibrium. Every gradient is an invitation. Every difference is a tension yearning to be resolved. The air rushes from high to low, water seeps through soil, the crust of the earth groans and shifts, all in pursuit of a fleeting balance. And in this pursuit, the world is shaped and reshaped, sometimes gently, sometimes with violence. The slow drift of continents, the eruption of volcanoes, the slow compaction of sediment into stone, all are the legacy of pressure at work, patient and persistent. In the laboratory, pressure becomes a tool of revelation. By compressing gases, we unlock the secrets of their behavior. By subjecting materials to extremes, we discover new phases, new properties, new possibilities. The diamond anvil cell, a device no larger than a thimble, can create pressures rivaling those at the center of the earth, squeezing atoms into patterns never before seen. Under such conditions, matter behaves in unexpected ways. Metals become insulators, gases become solids, familiar substances are transformed beyond recognition. Each experiment is a testament to the power of pressure to reveal the hidden potential of matter, to coax forth possibilities that would otherwise remain forever dormant. But for all our mastery, pressure humbles as much as it enlightens. Its workings are often subtle, its effects sometimes catastrophic. A diver descending into the ocean feels the weight of water increase with every meter, a force that can distort the body's chemistry and threaten consciousness itself. The decompression sickness known as the bends is a grim reminder that pressure is not merely an abstract number, but a reality to be respected. Our bodies, adapted to a narrow range of pressures, are fragile in the face of extremes. Yet our fascination with pressure is not simply a matter of survival or curiosity. There is a deeper resonance, a recognition that pressure is a metaphor as well as a mechanism. The word itself slips easily into our language of emotion and experience. We speak of feeling under pressure, of bearing burdens, of being crushed by expectation or driven to excel. The language of force and resistance, of compression and release, becomes a way to describe the invisible dynamics of our inner lives. Just as the physical world is shaped by gradients and equilibria, so too are our thoughts and feelings. There is a quiet poetry in this correspondence. Just as a cloud forms when air cools and pressure drops, so too do ideas sometimes crystallize in the rarefied spaces of reflection when the pressures of daily life recede. Conversely, as pressure builds, within clouds, within hearts, there may come a breaking point, a sudden storm, a release of pent-up energy. The lines between the physical and the metaphorical blur, and we find in nature a mirror for our own struggles and triumphs. Yet pressure is not merely a source of stress or strife. It is, on a deeper level, the engine of transformation and growth. In the depths of the earth, it is pressure that turns carbon into diamond, that forges minerals of breathtaking beauty and complexity. In the crucible of the cosmos, it is pressure that ignites stars and drives the fusion that lights the galaxies. In our own lives, too, it is often pressure, the necessity to act, to adapt, to endure, that compels us to become more than we were. In the right measure, pressure is not the enemy of life, but its catalyst. Let us pause, then, and listen for a moment to the quiet, persistent beat of pressure within and around us. It is there in the soft sigh of wind through the trees, in the gentle pressure of a hand held in comfort, in the rush of blood through arteries, in the tension of waiting, in the sudden release of laughter. It is present wherever forces meet resistance, wherever boundaries are tested, wherever the world is in flux. The mysteries of pressure are many. At the quantum level, the very existence of pressure is a consequence of the ceaseless agitation of particles, each one jostling against its neighbours, never at rest. The Pauli exclusion principle, a rule as strange as it is fundamental, forbids certain particles from occupying the same quantum state, an invisible law that gives rise to the pressure that supports white dwarf stars, and, by extension, the very fabric of matter itself. Pressure, it seems, is woven into the deepest laws of reality. And yet, for all its ubiquity, pressure resists our efforts to pin it down. It is not a substance, not a thing that can be pointed to or held. It is a relation, a consequence, an emergent property of countless interactions. To measure pressure is to measure the outcome of innumerable collisions and exchanges, to glimpse for a moment the hidden choreography of the world. Pressure is also the gatekeeper of thresholds. There are critical points at which the world changes character, boundaries where the familiar gives way to the unknown. Water, for example, behaves in startling ways at the triple point, where solid, liquid and gas coexist in delicate equilibrium, an exquisite demonstration of the interplay between pressure and temperature. Beyond the critical point, distinctions vanish, and matter enters a realm where intuition falters. Such thresholds are reminders that the universe is not static, but mutable, and that pressure is often the key to transformation. In the realm of the living, pressure is felt not only in the pulse of arteries or the intake of breath, but in the endless negotiation between inside and outside, self and world. Every cell is a fortress, its membrane a boundary across which pressures are balanced and maintained. The osmotic pressure that dictates the flow of water, the turgor pressure that gives plants their rigidity, the minute differences that allow nerves to fire, all are instances of life's dependence on the careful management of pressure. To live is, in a sense, to maintain a difference, to sustain attention across boundaries, to hold the world at bay and yet remain open to its gifts. Our understanding of pressure, profound as it is, remains incomplete. There are mysteries yet unsolved. The behavior of matter at the cores of giant planets, the nature of the pressures that may exist in the vacuum of space itself, the subtle effects of pressure on the chemistry of life. Each question is an invitation to explore further, to wonder anew at the elegance and complexity of the world. Yet perhaps the deepest lesson pressure offers is one of humility and hope. For pressure is not a force to be conquered or eliminated, but a reality to be understood, respected, even cherished. It is the pulse of the world, the sign of life, the source of both challenge and possibility. In its presence, we are reminded that existence is not static, but dynamic, not a state, but a process. We are, all of us, shaped and reshaped by pressures seen and unseen, internal and external, physical and emotional. In the quiet hours of the night, as the world slows and the mind drifts, there is comfort in knowing that pressure, for all its power, is also a source of connection. It binds us to the earth, to the air, to one another. It is the reason we can stand, breathe, love, endure. In every heartbeat, in every sigh, we feel its presence, a reminder that we are, in the most fundamental sense, participants in a vast and intricate dance, each step shaped by forces both ancient and ever renewed. As the darkness deepens, one might find oneself listening for the subtle rhythms of pressure, the gentle push and pull that underlies all things. In the hush, there is space to marvel at the wonder of being, to sense the invisible currents that sustain and challenge us, to feel for a moment the heartbeat of existence itself, steady, persistent, mysterious, and full of possibility. And somewhere, just at the edge of perception, the pulse continues, inviting us onward into the unfolding story, where new mysteries await in the silent depths of the world. As our journey through the quiet power of pressure drifts to a close, we watch its unseen hands gently sculpting oceans and skies, like a comet tail fading into the hush of space. Let your thoughts float softly on these silent forces, and when you're ready for more Dreamtime tales, return to drift once again through the gentle mysteries of our wondrous world.